Alright guys, wanted to get back onto the little Atlas lathe project a little bit, and this is kind of an update. Main thing I wanted to address was I've had several questions and got another one yesterday or the day before about the accuracy of this lathe, and had I checked it for accuracy, what kind of tolerances I'm getting. The short answer is no, I haven't. I, at this point in time, consider it a non-issue. As I'd stated before, at some point in time I may need to go back and rebab the headstock. The big variable in all of this that I don't know yet, and I haven't taken the time to really test it, is my spindle bore in alignment with the bed. The main components that are going to be an issue here are the headstock in relation to the bed, in relation to the tailstock. All three of those are going to be interrelated, and those are the only things that I feel on this particular setup can be an issue. So let's kind of go over it a little bit. I'll tell you what my thoughts are on it and why I think it's the way it is. So let me move the camera down here so we can see, and I'll give you my little 2 cents real quick. Okay, maybe we can kind of see here. Hopefully this will give you enough of an overview of what's going on. What I've got here are, we're looking at the lathe, of course, from the front. Now, accuracy-wise, what you're going to see on a normal lathe is we're seeing a lot of wear in the bed right at the headstock end. Most of the life on these older lathes, whether it be an Atlas, South Bend, my Sheldon, whatever they are, they spend most of their life working right here, probably within the first 6 inches of the chuck. So normally you'll see wear in the bed at that point. Well, we've shortened this bed up, as we know already, so we've eliminated hopefully most of the possibility of the wear in the bed. For all intents and purposes, we're going to say that when we shortened up the bed and moved everything from the headstock in towards the tailstock, we've eliminated the major wear area. So hopefully we've cut down on that, and we're going to say that we're hopefully on pretty much a fresh bed for the rest of the length. So we should, in theory, have a relatively flat, level, square bed to the world. When we put the headstock on, it was machined by Atlas originally, of course. I'm going to assume that everything is square there. Like I say, there could be some out of parallel, we'll say, in the headstock in the way it was babbited originally, or the way it was set up, because it would have probably been set up on a lathe bed and then bored and then babbited. I'm guessing the way they did it. I could be wrong, but that's kind of my assumption. So that would be my only concern, is if our spindle is not parallel and level with the bed, or on the same plane as the bed. We want it to be parallel both vertically and horizontally. So we're going to say that could possibly be an issue, but I'm not overly concerned. The majority of the work that's done on this lathe is going to be under 2 inches, at the most probably 3 inches, so we've got very little movement. So anyway, now our carriage will traverse. We've got it, rather than a fully fixed production headstock, which would only, or a carriage which would only allow travel front to back. This one will traverse, and originally with this bed in its original configuration would have had, I think, 36 inches of travel for the carriage. The way it's set up right here, the maximum it can have, I believe, is about 16 inches. So we've got a whole lot less movement anyway for wear, but like I say, it's going to be, the places it's going to move are going to be from right there probably to about there. So we've got 2.5 inches of travel is all that this will actually traverse on this bed through the rest of its life, as long as I own it. The reality is, the way I set up most of the tooling, it's probably going to be set right there, and the carriage is going to be locked in position as close as I can get it to the collet closer within reason, and it'll be locked in position there, and the only movement it will, so there'll be no movement of the carriage on the bed. So we don't have any wear going to be there, or no variation that would be introduced by traversing the carriage. So while we're talking about the carriage, we've gone to a production cross slide on it, and we're using a hand lever closer. On the original cross slide with a hand wheel, there would have, I think they say there's 6.5 inches of travel. With the this setup with the collet closer, there's just over 2 inches of travel is all we have here. So we've got a whole lot less travel on the lubed surface. We've got, on the carriage itself, we've got, I believe, 11 inches of machine surface. On the production cross slide, there's 10 inches. So there's very little movement on there anyway, and we've got lots of support with the machine surfaces mating together. So in reality, there's not going to be any variation there, and length will be set consistently by the carriage stops on the end. So once those are set, everything's limited there. This is kind of a stupid machine. Once it's set up, it can only do certain things. On a standard lathe, you'd be able to traverse it easily. You'd have cross-slide movement. You'd have a compound movement. So here we've got no compound at all, so there's no compound movement there. So we've eliminated anywhere in any of the lead screws on any of the three axes, the cross-slide, the carriage for the cross-slide, the compound, or traversing on the bed itself. So we've eliminated those possible buildup of errors or buildup of wear in those positions. Cross slide will only move forward to back. That's the only movement we're going to have there. It's tight on there, so we've eliminated most of the play or buildup of tolerances. And on the short pieces that we're going to build, it makes no difference. The tailstock is basically the same way. We're going to have some side-to-side flex in this. So, and I'll adjust that a little bit more once we get closer to having this run, which this will be running next week, I believe, on a job. So we want to set our tailstock as close as we can get it to the front. And any variation that we would have in machining with the tailstock or any misalignment that we have is going to be taken up by the tooling. When you originally bought an Atlas lathe, if you ordered it with a production tailstock, it was bored at the factory from Atlas, so you were hopefully as close as you could be to perfectly parallel with the spindle axes. And so your 6 turret positions were bored on the proper plane with your spindle. If you bought the tailstock later on as an accessory to add on to your lathe, it did not come bored, so you bored it after you received the tailstock. That way you were still concentric with the machine, or hopefully you did a good enough job boring it that everything was still truly in alignment. Where these were all separate components that I put together, why there's a possibility of misalignment on the both probably vertically and horizontally to the spindle. Any inaccuracies there are going to be taken out by tool holders, and it doesn't matter what tool holder. This is a little sneak peek of the project that I've already got going on. I haven't started editing the videos for this, but this is an adjustable tool holder. It fits the 3/4 inch shank tools, and I built 5 of these. So, and the reason I built 5 is that's the amount of stock that I had. I bought a length of steel for this project, and I could get 5 tool holders out of it. So that's what I built. Now these accept a bushing to hold whatever drill, reamer, tap, whatever the case may be that you want to hold. So the first project on this mill on this lathe is going to be turning the bushings forks, and I've got 3 of these with 3/8 bushing holes and 2 of them with 1/2 inch bushing holes. So we're going to start with the 3/8 bushing holes, and any misalignment in the tailstock to the spindle, vertically or horizontally, is taken up by adjustment in this tool holder. So it adjusts once you get it. So within reason, you've got some variation that you can align that to be, say, drilling your hole center, or if you've got a center drill in these, why you can start off with them centered up just by adjusting your tool holder. So that'll, like I say, I haven't even started doing the editing on the videos for these, but we'll get to that here real directly and start this going on. But these will fit any of my machines. I've got 3/4 inch spindle holes in both this and the Logan turret lathe, and the Sheldon, I can use these smaller tool holders if I build an adapter. It's got a 1 inch bore in the turret. So anyway, the setup for this these bushings is really quite simple. We're going to put our 3/8 collet or 1/2 inch. We're not going to do any outside turning. We're just going to use standard round bar stock. The accuracy on that will be just fine for these bushings. And what happens is these bushings will get chamfered on both ends. They'll be center drilled or center pointed on the outer end, so that when I set them up to bore them for whatever size material we want to fit in there, or whatever size tool we want to put in there, whether it's a drill or, we'll have our center on there, and the other end will be parted off from it with a chamfer on the outside end. So this is really a simple little operation. 3/8 stock. What's going to happen is we're going to run it up into the first turret position, which is going to adjust our length. So we'll set our length on that, close our closer. We'll go back and we'll face and point the outer end of it. So by pointing it, we're going to put our bevel on the same time we face that off. Second position, we'll go back, we'll center point that, or center drill it, so that we've got that marked on there. The next operation will be, we'll start the parting tool, which will have a rear tool post. I'm working on the rear tool post now. And we'll part that partially off. Then we'll have a bevel tool, or it'll probably be a 90 degree, 45 on each side. We'll run back in off of the front tool post. That will give us our bevel on the front edge and begin our chamfer on the next piece of stock. Then we'll come back and finish parting it off. Now, those pieces are only, for the 3/8, I believe they're 1/2 inch long. For the 1/2 inch bushings, I believe they're 5/8 of an inch long. So we're only working on 1/2 inch of material. So any accuracies in that is going to be non-existent. You know, that's not going to be an issue. So a lot of people think maybe I should have taken more time to check the accuracy of this lathe and make sure that everything was straight. But for the class of work that it'll do, it's going to be very, very good. I'm not really concerned at all. As we work with this lathe, we're making changes already onto the way I've set it up and some of the things that I've done. So if I need to make changes later on, that's fine. We'll make those changes as we do more complicated setups and start doing things with this work. On the products that I produce on the production machines, whether it be on my Sheldon, and I just did a little video on running that with a turret tailstock and production cross slide on it. I'll put a link up there to it someplace. Those are parts that either I'm going to install through the shop or they're going to be sent out to customers, and they have to be within the specs that I've drawn for those parts, and they have to be right. You know, I can't have a variation in those. I want everything to be consistent and be exactly the way I want it. The same holds true on this lathe, but all of my little Atlas machines, whether it's this lathe, whether it's my little Atlas mill or my shaper, those are, I'm going to consider them hobby projects. Even though this lathe I do have some things in mind to run off of this lathe, this is kind of a hobby portion of my shop. So I consider it a hobby. If I make changes, if everything's not perfect, we'll adapt to it. I'm having fun with this project. I still got a lot to do. There's a lot of things that are still going to be done on this lathe. Changes I'm going to make already. I've mounted the electrical switch up here on the right hand side on a Atlas. You know, we've seen that already. I'm going to move that switch for now, or as soon as I build the post for it, I'm going to move that switch down here to this end of the headstock. A couple of reasons for it. One is most of the controls you'll see on these smaller machines are on your left hand end. Originally I was going to mount an original Atlas switch down here where it would have originally mounted. The reason I'm not doing that, at least at this point, is it's a little bit crowded down here already with a turret, with a production stop. Why, it's gotten a little crowded down here. There's room for it, but I haven't decided exactly how I want to set that up. So for now it's going to go up here. Clean that up a little bit. Plus it'll get it out of the way from this end of the lathe. I guess a lot of the things that are going to be done on this lathe I'm going to video for you guys, and it's just a little cleaner without me having to reach across the camera and do things like that, because this end of the lathe, probably not this exact set, well, I know it won't be this exact setup. It's just a little more convenient for me rather than reaching across in front of the camera. And the camera's predominantly going to be on this end of the lathe, whether it's on a tripod sitting back towards the tailstock more, or on some other mount on this end. It's predominantly going to be on that end, on the right-hand end of the lathe, and it's going to be a little bit better view for you guys, and hopefully we can just clean this end up a little bit more so I'm not reaching across and doing things like that. I haven't finished even welding up the drain pan. The reason being, I haven't figured exactly where I want to put the drain hole in it. Eventually this lathe will be set up with flood coolant, I believe. For now I've got a clone of a fog buster that I'm going to finish the machining on. We're going to go ahead and mount a fog buster style coolant on here. That way I can clean up the bed and everything fairly easily rather than having flood coolant and having that having that mess at this point in time. So that's why I haven't finished the drain pan. That will happen here before too long because I want to get the stand painted, and I haven't finished painting the stand because I want to weld a little tray on, probably on the right hand end underneath, to hold my little grease gun to grease this, maybe hold some whey oil, things like that, to put my lubricants on there where they can be in a little catch pan or a little solvent proof tray that will contain any drips or spills over there. So I'm going to attach something to the stand itself. Then the stand's got to be painted. After that, we'll probably start working on the cabinetry that's going to go underneath the stand, the whole tooling and that type of stuff. But there'll be several little changes that go along as we do things. I've got quite a bit more tooling going on for it. I've got some self-releasing threading tools that I've already built a couple. We'll probably do a couple more, and we'll video the ones that we do after that. I'm working on the rear tool post. Another little sneak peek. This is the block for the tool post. I just have to cut my tool holder position, and I think we're probably going to put a rocker just like the standard 4-way turret tool post. I was originally going to set it up for a blade style holder, and I may build another blade style holder down the road for a cutoff. At this point in time, I thought I would just set it up with 3/8 tooling like the standard 4-position tool post would have. So we're going to set it up very similar to that. Lots of changes will happen. You know, I've done a few things that I'm going to change a little bit differently now. I have not built a nose cap for this yet. I guess I better get around and do that. It should have a nose cap to protect the threads there. Not a big issue, but it's something I haven't done, so I may get around and do that here in the next couple 3 days. We'll see what's going on. Anyway, hopefully that'll give you a little bit of an overview why I'm doing what I'm doing, how I'm doing it, and maybe give you a few ideas anyway. So hopefully you found something helpful here. If you did and you haven't already, you might want to hit that subscribe button. If you hit the bell notification, you'll know when I put out a new video. And any comments, suggestions, complaints, discrepancies that you've got with the way I do things, well, leave them in the comments section for me below. And as always, guys, thanks for taking the time to watch.